So this is our Astorino. It's 99.5% 3D printed. It has a max payload of a half a kilogram, and it's a precise down to 0.1 millimeter, which for a 3D printed plastic robot is incredible. I know some of our competitors are at like 0.5 for their industrial robots. We're beating them with plastic. So the main break in the barrier to education on this robot, and you can see we have somebody, sir, have you ever used a Kawasaki before?
Not Kawasaki.
So we have somebody using a Kawasaki pendant, picking it up, and he's already moving the robot. So the barrier to entry with a lot of other robotics companies is the cost. So where you could get like a Fanuc for about 30 grand to get into it, or 20, you could get 4 or 5 of these to replace one Fanuc. These are very easy to get in. They're very cheap. They're very replaceable. And if you damage a part on it, like breaking it is always a very big concern in education. The main barrier to repair with a normal educational robot is immense. For this, you're probably paying $20 in filament to replace it. The number one most replaced part on a robot is your teach pendant. So people break this, stab it, drop it, kick it. I've seen people cut the cord, run it over with a fork truck. If I break this right now, there's a 3D print booth one space over. I'm going to go and have them reprint it. It'll probably be done overnight, and I'll have a new pendant for next to nothing. And then just the barrier to running it, it's extremely easy to learn. It's extremely easy. It's extremely industry friendly. This is the Kawasaki full-size pendant. It's the same one. If you look through the glass there, we have it Toyota. You can go straight from Kawasaki to Toyota. You can go straight from a Kawasaki training course to getting a job at Toyota. I've trained more Toyota employees than I can count, and I could do it with that pendant as easily as I could this one.